Hi, everybody, and welcome to Is the Universe Infinite? Your favorite nighttime spiral into the deepest, weirdest corners of existence. Picture this. You're weightless, adrift in total silence, a soft blur of starlight brushing your cheeks. Above you, below you, all around space stretches endlessly in every direction. A velvet curtain dotted with cold, ancient pinpricks of light. It's beautiful and unsettling because no matter where you look, there's more and more and more behind now. Here's the reality check you didn't ask for. Even if you had a spaceship and 14 billion years of snacks, you probably wouldn't survive long enough to hit a wall, assuming one even exists, which, spoiler alert, no one's entirely sure about. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And drop your location and local time in the comments, because if we're going to have a cosmic crisis, we might as well know where everyone's panicking from. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You drift through the black, a passenger in the strangest, slowest moving tour bus imaginable. The universe itself. You're not flying. There's no wind to cut through, no engine humming in the background. Just gliding, a sense of motion without resistance. You pass stars like distant headlights and galaxies like neon clouds scattered across a glass pane. The first thing to know, you're not even close to the edge, if such a thing even exists. Earth sits tucked inside one tiny neighborhood of an unfathomably massive universe. Not big like a city, not big like a country, big like we don't have the right muscles in our brains to stretch that far. Your entire solar system is a speck inside a galaxy that's itself a speck among 2 trillion others we can currently detect. And that's only within the observable universe, the part we can see because light has had enough time to reach us. But more on that in a bit. Tonight, you're the stargazing goldfish. As you move deeper into the void, the stars thin out. Galaxies go from tightly packed to scattered. The air, which there wasn't much of to begin with, is gone entirely, replaced by nothingness that still somehow has temperature and energy and quantum fluctuations doing their twitchy little dance. Historians still argue whether the earliest thinkers truly grasped the vastness of what was overhead. The Babylonians saw patterns and cycles in the stars. The Greeks, like Aristarchus, even dared to suggest the sun, not Earth, might be the center of things. Bold. Wrongish, but bold. One mainstream fact, by the time you hit the 20th century, Edwin Hubble comes along and drops a cosmological bomb. Not only is the universe big, it's expanding. Every galaxy is fleeing from every other one. Space itself is stretching. Cue existential panic. Here's a fun or horrifying fringe tidbit. There are theories suggesting that some regions of the universe are so far away and moving so fast that their light will never reach us. Not even if we wait billions of years. Those places might as well not exist from our point of view, ghost regions slipping beyond the event horizon of our observable bubble. You float past a galaxy 10 billion light years away. Its light has been traveling toward you longer than Earth has had continents. The stars inside it are dead. Their glow a kind of ancient voicemail you're only just listening to now. You wonder, if you kept flying straight, would you ever hit something, a border, a wall, or would you just keep gliding forever? Cosmic horizon lines ripple past you. You realize you're moving through space, but also with space, like a marshmallow in a rising loaf of bread. No matter where you are, space is inflating all around you. You are, scientifically speaking, stuck in the dough. So how do you feel right now? Small, that's fair. A little dizzy? Even better. That means it's working. You're getting in tune with the vibe of the cosmos. Confusing, humbling, and gently overwhelming. The ancient Egyptians imagined the sky as the body of a goddess arching over the earth, her toes and fingers pressing down at the edges of the world. That version had a nice cozy ceiling. These days, you float in a world with no ceiling and possibly no floor. You pass through a cold zone, a patch of space where microwave radiation dips unexpectedly. Some scientists think it's just a statistical blip. Others? They whisper about possible alternate universes brushing up against ours. It's fringe, sure, but this whole place feels fringe. There's a flash, no, a memory, a signal from deep time. We'll get to that later. But it hints at something ancient, something that suggests our universe may not be a closed loop. It might be more like a balloon with no surface or a highway with no exits. One direction, all gas, no brakes. And you? You're a speck on a rock inside a minor galaxy, inside an expanding fabric that may never end. You sigh. Or would if there were air. The weirdest part? You're not scared. You're fascinated. Maybe even sleepy. The stars shimmer quietly as you pass, each one an echo of fusion and gravity. Each one a candle in the grand cathedral of whatever this is. You squint toward the black, hoping to spot a border, an end, a sign saying you are now leaving the universe. But nothing comes. Just stars, just silence, just the thought. What if it really does go on forever? You drift onward, deeper into the dark, with that question still trailing behind you like a thought-shaped comet. Is there an edge? If the universe is infinite, then no edge, right? But if it's not, if it's just very, very large, then maybe, just maybe, there's a wall out there somewhere, a final border, a cosmic fence post hammered into the void. And that's where things get weird fast. Let's rewind a second. You're currently floating inside what scientists call the observable universe, a sphere around Earth that's about 93 billion light years across. That's just the part we can see. Not because that's all there is, but because light hasn't had time to reach us from anything farther. Light's fast, sure, but the universe is older than you think and expanding faster than you'd prefer. You look around and think, well, I see galaxies in every direction, so there must be an edge out there somewhere. Logical, sure, but also wrong, because no matter how far you go, you'll always be in the middle of your own observable sphere. That's not ego, it's physics. The light reaching your eyes or spaceship sensors, let's pretend you're fancy, is coming from the edge of your bubble. But someone in a galaxy 5 billion light years away, they've got their own bubble just as big, centered on them. It's bubbles all the way down. And so the question becomes, does the universe have an actual edge? Not just a limit to what we can see, but a place where space stops. A hard boundary, a final nope, turn back sign. Well, probably not. At least not like that. Remember that feeling from childhood when you first learned Earth doesn't have an edge where you fall off into space? It's kind of like that. The universe might be finite but unbounded, like the surface of a sphere. You can walk forever without hitting a wall, but you're still looping around a contained surface. In this analogy, you're moving in 2 dimensions over a 3-dimensional shape. Now imagine you're in 3 dimensions, moving through something 4-dimensional. Congratulations, your brain just did a backflip and face planted. Here's a mainstream historical gem. When Einstein rolled out general relativity in 1915, he imagined a static universe, unchanging, eternal. But within a few years, solutions to his own equations suggested something more uncomfortable, a dynamic universe that could expand or contract. He hated it, added a fudge factor called the cosmological constant to keep everything stable. Later, he'd call that his greatest blunder. Relatable. What came next? Edwin Hubble, the overachiever. He pointed a telescope at some fuzzy sky smudges and discovered they weren't stars, they were entire galaxies. More than that, they were moving away from us. The farther away they were, the faster they ran. The universe wasn't static. It was expanding. Cue the mic drop. You peer into that expansion now. Galaxies don't just fly through space. They're carried by space stretching between them. You try to imagine an edge. But how can there be one when the fabric itself is ballooning? It's not like galaxies are hurtling toward a wall. The space between them just keeps growing. You're not moving away from your neighbor, the street is getting longer. Some fringe theorists go further. What if the universe does have an edge, but it's not spatial? What if it's an energetic edge, or a dimensional one, something like a membrane, thin and invisible, where the rules of physics bend or snap entirely? It's the kind of thing that makes quantum physicists bite their nails and cosmologists drink more coffee than is healthy. And yet, for all our tools, Hubble, Webb, radio telescopes, math so advanced it feels like witchcraft, we still can't see the whole show. Historians still argue whether early astronomers even grasped the scale of the cosmos, or if they were simply mapping celestial wallpaper. Turns out, we're still guessing too, just with fancier tools and more decimal places. You pass through a region where time feels strange. A dense patch of old galaxies whizzes past. You get the eerie sense that they're not just far away, they're old. Their light bent and bruised by billions of years of travel. You think, if there's an edge out here, it's hiding behind time itself. And that's the kicker. The farther you look, the further back in time you see. You're not looking at what's there now. You're looking at what was there. Some of the galaxies you see tonight, they don't even exist anymore. Just echoes, just ghosts. It's like watching fireworks from a century ago. So you keep floating deeper into the dark, staring at these ancient fireworks, wondering if the black ever breaks, if there's ever a spot where the stars run out, the galaxies go silent, and all that's left is a smooth, perfect nothing. But the void just keeps going, and your mind keeps spinning. If the universe had an edge, wouldn't there be something outside that edge? And if there's something outside, isn't that just more universe? It's the snake eating its tail. Every time you try to pin down the boundary, the thing just gets bigger, more elusive. Like a room with mirrored walls, your reflections stretch on forever, even though the space is limited. So for now, you let go of the question, not because it's answered, but because it might not have an answer. Not a satisfying one anyway. That's the beauty and the horror of it. As you drift, a nebula blooms around you like a soft jellyfish. You watch the slow pulse of its gas tendrils reach into nothing, each wisp a reminder. Even in silence, there's motion. Even in the void, there's life, sort of. And somewhere far behind you, Earth spins on. Still round, still weird, still surrounded by people wondering if they'll ever see the edge of something that may not have one. You keep moving forward. The stars don't stop. You're still drifting, still suspended in that serene, bottomless black. But something subtle has changed. You're beginning to notice the rhythm of distance, not just how far things are, but how their light behaves as it stretches toward you. Galaxies ahead seem to bleed red, not from injury, but from a silent rule baked into the universe itself. This is where the cosmos starts enforcing its speed limits. You hover now at the edge of a glowing cloud of ancient stars, your cosmic rest stop. But don't expect a bathroom or vending machine, just photons, old, tired, red-shifted photons. Light, as it turns out, isn't just illumination, it's a time traveler. And in this universe, it's fast but not infinitely fast, roughly 297 kilometers per second, the fastest thing in existence. But even that speed has limits, and the consequences are huge. Let's say you shine a flashlight into the void. The beam stretches out forever, if uninterrupted, but it takes time. That time becomes distance. That distance becomes isolation, which means the farther away something is, the older the light we see from it. When you look at a galaxy 10 billion light years away, you're seeing it as it was from 10 billion years ago. You don't see the galaxy as it is, you see a memory of it, preserved in light. So what happens when something gets too far away? You might assume light will eventually reach you, even if it takes billions of years. Logical, but wrong again. Because here's the mind melter. The universe is expanding faster than light can keep up, like a treadmill that speeds up the farther you walk. Galaxies beyond a certain point are being pulled away by expanding space faster than their light can ever reach us. This invisible border is called the cosmic event horizon, and it's terrifyingly final. Anything beyond it is, for all practical purposes, lost to us, forever. Not because it's hiding behind a wall, but because space itself is expanding so quickly that light from those regions can never catch up. It's like trying to swim upstream against a river that's getting faster by the second. You squint at the dark beyond that horizon and realize, even if you waited 100 trillion years, no telescope would ever reveal what lies there. It's gone, not destroyed, not hidden, just beyond knowing. A historical fact to anchor your brain. In 1965, two scientists, Arno Penzias and Robert Wilson, accidentally discovered the cosmic microwave background, a faint uniform hum of radiation left over from the Big Bang. They weren't looking for it. In fact, they thought it was bird poop in their radio antenna. Classic science. But what they'd stumbled upon was the oldest light in the universe, light that's been traveling for over 13 billion years. That light marks the furthest edge of what we can possibly observe. Not a physical wall, but a glowing photograph of the universe's first moments. A baby picture, if you will. And even that image is blurry, stretched by time and expansion until it hums at microwave frequencies. You bathe in it every second, whether you notice or not. Kind of poetic, right? But let's slide sideways for a second. One fringe theory says that the expansion of the universe isn't just pulling galaxies apart. It's literally ripping space-time into unconnected fragments. Regions of space so far apart that their timelines no longer sync with ours. That's not just distance. That's cosmic exile. Historians still argue whether the ancients suspected there was a speed limit to the stars. The Greeks thought light was instantaneous. The medieval Islamic world made early guesses about its motion. But it wasn't until the 1670s that Danish astronomer Ole Romer measured the delay in light from Jupiter's moons and realized light takes time. The stars don't shine instantly. They whisper through the dark. You feel that delay now. Every shimmer, every glow echoes. Even the closest star is 4 light years away. If it exploded right now, you wouldn't find out until the next US election cycle, which somehow feels equally catastrophic. And here's the joke. The more you understand about how fast light moves, the more you realize how isolated you are. The speed of light isn't just a limit, it's a barrier. It tells you what you can interact with and what you never will. It defines the edges of your reality, even if the universe itself has no physical borders. You drift past a quasar, one of those galactic cores that blasts energy like a death metal concert. It's old, it's loud, and it's impossibly far away. You're not seeing what it's doing now. You're seeing what it did when Earth was just cooling off from its volcanic teenage years. Back when oxygen wasn't even trendy yet, light from that quasar left before the dinosaurs, before trees, before eyes. And it's only just now brushing past your imaginary helmet. You reach out, try to touch it, but there's nothing there, only delay, only a ghost. You keep drifting. The cosmic speed limit doesn't just affect your sight, it affects your movement. Even if you hopped into the fastest spaceship ever built, you'd never reach the speed of light. Physics simply won't let you. As you accelerate, your mass increases and time slows down. That's not science fiction, it's relativity. The faster you go, the more distorted your experience becomes. Want to reach another galaxy? Hope you packed a few billion years of podcasts. And yet, some distant part of you kind of likes the limit. It's comforting in a way, a reminder that the universe plays fair, that there are rules, that the stars aren't just showing off, they're on a delay just like everything else. You can't cheat time. You can only observe it, glowing faintly in every direction. So here you are, floating inside a bubble of perception, a shrinking island of knowable space in an ocean of unreachability. Every second, more galaxies drift beyond your grasp. The visible universe gets smaller, not in size but in potential. It should feel tragic, but instead it feels quiet, peaceful. The light fades. You drift forward, slower now. Behind you, stars vanish one by one, their light finally outpaced by the swelling black. And still you wonder, if I can't see it, if I'll never reach it, is it still part of my universe? Maybe. Or maybe you're just a goldfish in a very clean bowl. Still floating, still gliding through the dark like a dreamer in zero gravity. But now something strange begins to tug at your perception, not a force, not a gravity well, but an idea, a shape. The growing sense that space itself isn't just out there, it has form. It bends, it stretches, it expands. So tonight we bring out one of cosmology's favorite party tricks, the balloon analogy. Imagine for a moment you're not drifting through space, but drifting on it. You're a tiny speck stuck to the surface of a giant balloon. The balloon isn't floating through a room, it's inflating. And you? You're just watching the other specks, galaxies, move farther away, much to ion birthday, not because they're flying off, but because the surface between you and them is stretching. No matter which direction you look, Everything seems to be moving away from you, which at first makes you feel weirdly special, like maybe you're at the center of something. But twist the perspective. If you were on any other speck, you'd see the same thing. Every galaxy observes every other galaxy moving away. There is no center, just expansion. Space itself is the star of the show. You glide now along the invisible balloon surface, watching galaxies recede like ships fading into fog. The more distant they are, the faster they seem to go. That's not because they're zooming through space, it's because space is zooming them away from you. It's a gentle trick, really, one that even Einstein didn't see coming. He once imagined the universe as static, stable, unchanging. But the math said otherwise. It said the fabric of space could stretch. And when the evidence finally backed it up, astronomers had to face a new idea. The universe isn't just in space, it is space. And that space is expanding, relentlessly, quietly, like your inbox. A historical nugget here. Belgian priest and physicist Georges Lemaitre first proposed the idea of an expanding universe in the 1920s. He even suggested that everything began from a primeval atom, a single point that exploded outward. People laughed. Then Hubble backed it up with redshift data. Nobody laughed after that. You now coast along this stretchy surface, marveling at how it holds together. It's not like a rubber balloon that eventually pops. The expansion doesn't happen into anything. It just is. That's the trickiest part. You want to imagine the balloon inflating inside a room, but there is no room. No outside. The balloon is all there is. Its surface is space, and we're smeared across it like cream cheese on the weirdest bagel ever conceived. And here's the even stranger bit. The balloon has no edge. If you walk in one direction long enough, you'll end up where you started. No borders, just loops. A finite yet unbounded shape. That might be what our universe is doing. Not necessarily balloon-shaped, but curved in a way that wraps around itself without needing a boundary. Fringe minds take it even further. What if the balloon has holes? What if there are other surfaces, other balloons hovering next to ours, invisible, untouchable, yet just as real? Parallel universes, bumping elbows in a multiverse too vast to even imagine, each with its own physics, its own flavors of space and time. You might be drifting through vanilla cosmos, while pistachio and mango swirl beyond your reach. Historians still argue whether early Indian or Mesoamerican thinkers came closest to imagining this kind of endless but contained universe. Some ancient texts hint at cyclic models. The universe expands, collapses, then begins again. Like lungs inhaling and exhaling over epochs. Turns out even old cosmology had poetic flair. But back to you. You coast farther now, deeper into this balloon universe, and you start noticing that expansion isn't uniform. Some regions stretch faster, some lag behind. Matter clusters here, spreads thin there. It's messy, uneven, which makes sense gravity's still playing with the fabric, like a child tugging at a bedsheet. It pulls, it warps, it resists. And speaking of resistance, here's a weird twist. While space is expanding between galaxies, the galaxies themselves don't stretch. Neither do you, or your spaceship, or your bones. That's because gravity and atomic forces are stronger than the expansion at small scales. So don't worry, you're not about to unravel into stringy spaghetti, at least not here. Not yet. Still, you can feel the bloat, the slow, ancient swelling of space. It doesn't tear, it doesn't pop. It just keeps becoming. A low, soft breath that never ends. You float past a galactic cluster locked in a cosmic tug-of-war. The galaxies are trying to escape each other, thanks to expansion, but gravity says not today. They're stuck, swirling in a dance that might last billions of years. A cosmic soap opera full of betrayal and fusion events. You realize something. This expansion isn't just a fact of the universe. It defines the universe. It's not a feature of space. It's what space does. It's how space lives, quietly blooming, always outward, never back. And now the question returns. If the universe is expanding, what is it expanding into? You wait. The answer doesn't come. Because there may be no into. There may be only more space, more time, more distance. The balloon isn't inflating into a room, it's creating the room as it grows. Your thoughts begin to slow like a marble rolling to rest. You feel small, yes, but also part of the pattern. A speck on the surface of a breathing cosmos, held in tension between gravity and motion, silence and scale, the old and the new. You drift. You let the balloon carry you. You don't know where the edge is or if it exists. But maybe that's not the point. Maybe the real magic is that there's always more to discover. And just like that, another galaxy fades behind you. You drift on. The galaxies thin around you, but the black somehow deepens. Not darker, but denser. Like you're not just in space anymore, but inside some invisible structure. And here comes a big idea, slow and deliberate, wrapping around you like the arms of a patient teacher. Space has shape, not shaped like a square or a triangle. No corners here, no tidy boundaries, but shape in the deeper sense geometry on a cosmic scale. The way space curves, the way light travels, the way matter clusters, these all hint at whether the universe is flat, curved like a saddle, or wrapped like a sphere. So go ahead, press your cosmic cheek against space and ask, is this thing flat enough for pizza? The answer, surprisingly close to yes. But let's not get ahead of ourselves. First, imagine a triangle. On paper, it adds up to 180 degrees. Now draw that triangle on a beach ball. Suddenly, the angles stretch. They total more than 180. But if you draw it on a Pringle chip, now it's less. Welcome to curved space. On a balloon, you've got positive curvature. On a saddle, negative curvature. And on a perfectly flat, infinite sheet, that's zero curvature, a flat universe. So what about ours? You float between galaxy clusters and trace light paths that bend ever so slightly around invisible contours. You squint at the ancient glow of the cosmic microwave background, the baby light from the early universe, and measure the tiniest shifts. It's here that scientists have taken the universe's temperature with absurd precision. And guess what? All evidence points toward flatness, or more precisely incredibly near to flat, like within a 0.4% margin, which sounds small until you remember this measurement applies to the entire universe. But here's the trap. Flat doesn't mean infinite. It just means space isn't curving inward or outward, and at least not noticeably. It could still loop, it could still end, or not. Historians still argue whether our instruments are precise enough to tell the difference. Back in the early 2000s, astronomers used a satellite named WMAP to scan the microwave background. What they found were tiny fluctuations, temperature ripples, that revealed how matter and light behaved shortly after the Big Bang. These ripples matched the fingerprints of a flat universe. Later, the Planck satellite confirmed it, with even more detail. Like the difference between an 8-bit photo and a 4K deep space selfie. But even with all that data, the question haunts us. Is it truly flat or just so large that it appears flat from our little corner? It's like standing in a field with fog in all directions. Everything feels level. But that doesn't mean you're not standing on the surface of a massive sphere. You just can't see the curve. You drift now near the edge of a vast void, a cosmic desert between galactic clusters. Light here takes a lonely path. The silence feels thicker. And yet, here too, the rules apply. Gravity still shapes the pathways. Space still obeys the geometry. Even in absence, the fabric is active. Fringe theories begin to creep in again. What if the universe's shape isn't one of the three classic types, flat, sphere, or saddle, but something more exotic? Like a toroidal loop, a donut, essentially, where space folds in on itself in every direction. You could travel forever in a straight line and end up behind yourself, like Pac-Man on a cosmic arcade screen. Or what if it's a hyperbolic fractal, a never-ending self-replicating geometry that spirals down into smaller and smaller infinities? It's mathematically possible, though currently just a theoretical fever dream shared by physicists on too much coffee and not enough sleep. And remember, if space has shape, it also affects time. Gravity warps both. Time slows near massive objects. This isn't just theoretical. GPS satellites have to adjust for it, or your directions to that late-night taco place would be way off. So imagine what shape does at the cosmic level. Imagine time bending subtly as space curves, weaving a four-dimensional tapestry we only barely understand. You pass a star on the edge of a galactic filament, one of those long cosmic strings that connect the universe like veins. You think about how light from that star bends not sharply but delicately as it moves through space shaped by gravity. Every photon in is tracing the curvature. Every path is a clue. And you're riding the contours, blindfolded, trying to guess the shape of the invisible floor. You remember old myths, how ancient peoples imagined the earth resting on the back of a turtle or suspended in the branches of a world tree. Those were shapes too, human attempts to define the undefinable. Historians still debate whether early cosmologies were metaphors or serious models. Either way, we've always tried to imagine the shape of things. And here you are, thousands of years later, asking the same question, with better math and worse attention spans. Your ship, or maybe just your dream self, drifts silently through geometry you can't see but feel. The stars around you whisper their alignment. Gravity pulls not down, but inward, toward mass. Space flexes, time wobbles. You begin to wonder if the universe really is flat. Does that make it infinite? Or is it just really, really wide? The answer? Unclear. Maddeningly so. Even in a flat universe, we could still be looping, still inside a volume with no boundaries but weird topologies. Or maybe it truly is endless, an infinite pancake, spread thin with stars and dark matter syrup. You chuckle at the image, the universe, as breakfast. Carl Sagan would approve. The light ahead starts to bend slightly, a reminder that no line in space is ever truly straight. Everything is curved by something. You follow that curve, relax now, letting the shape of space cradle you. No walls, no edges, just patterns. Soft waves in the fabric of everything. Maybe space isn't flat. Maybe it's just sneaky. You're still coasting, still weightless, but now the fabric beneath you begins to hum. Not with sound, but with energy. A quiet tension, like a rubber band gently stretched between unseen fingers. And in that tension, the biggest twist yet starts to rise like a ripple in calm water. The universe isn't just expanding, it's accelerating. That's right. Space isn't just getting bigger. It's getting bigger faster. And no one knows exactly why. At first, you feel the tug subtle like the pull of a slow tide. You look around at distant galaxies and see them not just receding, but doing so with increasing speed. The farther away they are, the faster they go, like an intergalactic traffic jam where the cars at the edge are punching the gas. It wasn't always like this. For most of the 20th century, scientists assumed the universe's expansion was slowing down. Makes sense, right? Gravity should pull things back together even if it takes eons. The cosmos, according to old models, was supposed to be coasting toward a halt, or maybe even reversing into a big crunch. Then 1998 happened. Astronomers studying distant supernovae, those big, flashy stellar deaths, made a shocking discovery. Those far-off explosions were dimmer than expected. That meant they were farther away than they should have been, which meant the universe hadn't just expanded, it had done so faster than expected. Cue the collective, science-wide, what the heck? That's when we met the mysterious player behind the curtain. Dark energy. No, not evil energy, just unexplained. A placeholder name for whatever is making the universe accelerate. It's the anti-gravity of cosmic drama, pushing instead of pulling, stretching instead of squeezing. Right now, dark energy makes up about 68% of the total energy in the universe. Your spaceship, your bones, your streaming queue are made of normal matter. That's less than 5%. The rest, dark matter and dark energy, stuff we barely understand, which means most of the universe is missing the instruction manual. You feel that now, not fear, just awe, a quiet acknowledgement that the machinery behind it all this is more complex than any human ever anticipated. Historians still argue whether ancient thinkers had any inkling of a force like this. The Taoist notion of an eternal, flowing nothingness gets brought up a lot. But let's not kid ourselves, nobody in 300 BCE, China was writing equations about vacuum energy density. Still, the idea of a hidden force shaping the cosmos, that's old, that's primal. You imagine the universe as a massive loaf of raisin bread dough rising in the oven. The raisins are galaxies. As the dough expands, the raisins move away from each other. But now picture that dough suddenly rising faster, an invisible yeast jacking up the pace. That's dark energy. The universe's yeast, just way less delicious. And here's where it gets truly weird. The more the universe expands, the more dark energy seems to dominate. That's because it doesn't dilute. Normal matter spreads out as space grows. But dark energy? It's like it fills the space as it appears, like air inflating a balloon from the inside, always adjusting to volume. You pass a cluster of galaxies being subtly torn apart. Not violently, not like some dramatic sci-fi laser, but by this slow, patient force pulling everything away from everything else. Over unimaginable time frames, gravity will lose, stars will drift, structures will dissolve. Some scientists call this future the Big Freeze. Others, more melodramatically, call it heat death. Both describe a universe where everything becomes so far apart and so cold that nothing interesting can happen anymore. No stars, no warmth, just isolated particles floating in ever-darkening space. You feel it now, that distant, inevitable silence. But don't worry, that's trillions of years away. For tonight, you're just here to marvel. A fringe hypothesis rises in your mind. What if dark energy isn't constant? What if it changes over time, grows stronger, faster? In that case, things might end in a big rip. Picture the universe tearing itself apart, galaxies shredding, planets unraveling, atoms themselves ripped from their electrons. It's horrifying and fascinating, and totally unconfirmed. And yet, we do know this. The universe is growing faster, not slower. That acceleration is undeniable, which raises one more haunting question. Was there a time before dark energy dominated? Yes. About 5 billion years ago, gravity was still in charge. Galaxies were expanding away from each other, but slowing down. Then came the tipping point. Dark energy became the boss. And since then, the expansion hasn't just continued, it's gone turbo. You drift through this thought the way a feather drifts through a draft. No control, no resistance, just letting the motion happen. You picture the early universe as a crowded city street, galaxies bumping shoulders, gravity pulling them into clusters. Now it's more like a desert, fewer neighbors, more space. And soon, perhaps, nothing but cold, quiet distance. Historians still debate whether we're lucky or cursed to live during this middle time, a brief window where stars still shine and galaxies still dance. You pass a star being born in a nebula of warm gas. It won't last forever. But for now, it glows defiantly against the darkness, like a stubborn ember in a cooling fireplace. You wonder if space is stretching faster. Does that mean time is too? Kind of. Expansion and time are deeply intertwined. The fabric stretches in both directions. Time slows near massive things, but on a grand scale, the rate at which things happen is influenced by the expansion. If the universe accelerates forever, it may eventually leave no room for change. A kind of eternal stasis, not death, but endless quiet. But tonight, you're still moving, still exploring, still marveling at how space could be this strange and still let you exist at all. You tilt your head, figuratively, it's space you can tilt forever, and wonder if dark energy is truly a thing or just a mathematical patch on our flawed understanding. Maybe we're looking at gravity all wrong. Maybe space-time has layers we haven't peeled back yet. Or maybe, just maybe, this is how it was always meant to be. A universe that can never be held still, that refuses to coast, that stretches, expands, accelerates, not toward chaos, but toward change. You breathe in, the stars drift apart, and the silence grows larger. Now you're really feeling it, that creeping sensation that everything is moving away. Not because you're the problem, but because that's just how it works now. You are the center of nothing, yet everything seems to leave you behind. You stare at the deepening dark and realize there are things you will never see, not because they don't exist, but because their light will never reach you. You're brushing against the edge of the observable universe. But let's be clear, this isn't a wall. It's not the end of space or a Truman Show-style dome. It's just the limit of what light has had time to reach us. given the age of the universe and the speed of light. Imagine living in a forest so vast you can only see the trees close enough for their whispers to reach your ears. The rest? Still there, still growing. Just lost in the hush. This observable limit extends about 46.5 billion light years in every direction. You do the math, then shake your head. It's weird that a universe only 13.8 billion years old could have an observable radius that big. But remember, space itself has been stretching the whole time. It's like walking on an airport treadmill that keeps getting longer while you move. The distance between you and the edge, not what it was when the light left. So what's out there, beyond the bubble? Maybe more galaxies, more cosmic strings, or maybe just more nothing. But not nothing as in empty, but nothing that can ever reach you. It's not invisible, it's unreachable. You could send a message now, at light speed, and it would never arrive. That part of the universe is already gone from your future. You pause for a beat, let that sink in. There are regions of the universe whose stories will never touch ours. Never seen, never measured, never known. It's a cosmic version of left on read, and the number of unreachable galaxies increases every second. Some are already beyond your cosmic horizon. Others are slipping past it, so you float here in your metaphorical bed of stars. They vanish, not in a blink, but in a slow fade. Their redshift stretches until their light blends into the background hum of the universe itself. You remember the cosmic microwave background, that ancient glow from the Big Bang. It's the oldest light we'll ever see. Anything before it? Opaque, unobservable. The curtain closes at about 380,000 years after the universe's birth. So even if you built the fanciest telescope in history, aimed it at the sky, and waited forever, you'd never see past that glow. The early universe was too dense, too hot, too chaotic for light to travel freely. Fringe thinkers suggest that beyond our observable bubble may lie entirely different physical laws. Alternate versions of reality where gravity behaves differently, where time is elastic, or where stars never formed at all. These aren't stories from comics. These are real speculative models from real physicists, driven mad by the boundaries of data. Historians still argue whether ancient cultures grasped this idea of limits. The Norse imagined a world encased in layers, Midgard, Asgard, and beyond. The Hindus described a multiverse, where each bubble of reality floated in an ocean of cosmic breath. Whether poetic or profound, the point was the same. There's always more than you can see. You glide past a galaxy on the brink, its light just barely reaching your position. That light began its journey billions of years ago. Somewhere in that galaxy, a star may have exploded while dinosaurs still ruled Earth. You're only now getting the postcard. But that same galaxy, it's already moved beyond your grasp. If you sent a reply fee, it would never arrive. You are surrounded by ghosts. Not dead stars, but disappearing neighbors. Friends you never met and never will. The ultimate long-distance relationship. It's tempting to feel small, to imagine yourself a flicker in an indifferent cosmos. But there's another way to look at it. You exist right now in a tiny sliver of time where much of the universe is still visible. A cosmic golden hour, where the sky is full of stories. In another 100 billion years, many of those stars will be gone from view. Future astronomers, if they exist, may see only a fraction of what we see now. A darkening sky. Fewer galaxies, less evidence of the Big Bang. The universe itself will start to hide its past. So you're the lucky one. The curious ape with a front row seat to the greatest light show ever staged. You get to watch it fade in real time. You drift through the edge of observation. Past that, there's only inference, math, imagination. Whatever lies beyond can never confirm or deny itself. It's the part of the book permanently glued shut. But that doesn't stop you from wondering, does the universe go on forever? If it doesn't, what's outside? If it does, is it all the same? Or is this just one patch in a cosmic quilt too large to ever fold? A new thought flickers. Maybe the edge isn't out there at all. Maybe it's you, your senses, your tools, your perspective. Maybe the horizon isn't a barrier but a mirror. A reminder that what we call the universe is just the part we've been lucky enough to catch. You close your eyes, figuratively again, and let the edge pass through you. It doesn't block you. It simply marks where knowing ends and wonder begins. And that's not sad, that's beautiful. The further you drift, the more the darkness blooms, not as emptiness, but as presence. It's heavy now, velvety, cosmic. It presses softly on all sides, like the air just before a thunderstorm. You've floated past galaxies, danced along the surface of geometry, and touched the edge of what can be known. But now you reach a space where the rules get weird, where the familiar becomes slippery. Here, in the deepest stretches, you meet the ghost that haunts all of space. Infinity. The word rolls around in your mind like a marble on a table with no edges. Infinity. It sounds almost lazy, right? Like a placeholder for we don't know when to stop counting. But in cosmology, infinity isn't just a big number. It's a concept, a consequence, a possibility that's either profound or completely absurd. You float here, in the thought of it. Is the universe infinite? No one knows. But let's start with what might be infinite, space itself. If the universe is truly flat, and we've already seen that it appears to be, then it's possible that space goes on forever. Not in a loop, not in a curve, just on and on. You could fly in a straight line forever and never hit a wall. No wraparound, no return to start, just eternal forward. You start to feel it in your stomach, this idea of endlessness. It's the same vertigo you get standing on the edge of a tall building, only flipped inside out. You're not looking down into a pit. You're looking out into a place with no end, no fence, no outside. But does it make sense after all? We've never encountered an actual infinity in the real world. Everything we experience has limits, tables have edges, roads have ends, Netflix shows eventually get canceled. But space? Maybe not. The math allows it. Our best models don't require an edge. But here's the catch. We can't see beyond our observable horizon. So even if the universe is infinite, we can't ever prove it. We live inside a bubble. Everything beyond that bubble could just be more of the same. Or not. Historians still argue whether the ancient Greeks invented the concept of infinity or just feared it too much to deal with. Zeno famously tried to break motion into infinite steps and tripped all of Athens with paradoxes. Others imagined infinity as divine, untouchable, a thing for gods, not for mortals. Even today, many physicists get nervous about real infinities. They're often seen as bugs, not features. If your equation spits out infinity, it usually means something went wrong, a divide by zero moment, a physical model pushed past its limits. But in cosmology, infinity still hangs around like a persistent shadow, an unavoidable possibility. And it doesn't stop with space. What about time? You drift now through the ticking fabric of the cosmos and wonder, will this all go on forever? If the universe keeps expanding, accelerating, even then, yes. It may never end. No final crash, no rewind, just an eternal fizzle into cold darkness. And yet, if there was a beginning, a Big Bang, doesn't that suggest there could be an end? Possibly, but not necessarily. Time could go on. Just because a clock started ticking doesn't mean it must ever stop. It just needs batteries, and the universe has plenty of those. But infinity isn't just a spatial or temporal thing. There's also content. If space is infinite, then how many galaxies are there? Well, infinite. How many stars? Infinite. How many versions of you reading this script right now in a slightly different reality where you're wearing a hat shaped like a pineapple? Yeah, also maybe infinite. Enter the infinite universe paradox. If space is infinite and matter is evenly distributed, which on large scales it seems to be, then every possible arrangement of matter will eventually repeat. Somewhere out there is another Earth, another you. Maybe one where you became a professional yodeler. Historians still debate whether this is science or philosophy wearing a fake mustache. You drift past a nebula and wonder, is this the one or is it just one of trillions, each playing out a slightly different script? Some theories take this even further, suggesting an infinite multiverse, not just more space in our universe, but endless other universes, each with their own laws, constants, particles. Ours might just be one bubble in an eternal cosmic foam. This isn't sci-fi, it's a consequence of certain inflation models. And while it's far from confirmed, it's taken seriously enough to make your brain do somersaults. But here's where the gentle sarcasm kicks in. Infinity is kind of rude. You ask it a question, where does the universe end? And it answers, oh, sweetie, it doesn't. You try to picture it, and it just hands you a headache. Infinity is an answer that ends the conversation. It doesn't comfort. It doesn't explain. It just is, which is why scientists both fear and admire it. It's like trying to hold fog in your hands. Still, it's useful. Without the concept of infinity, calculus doesn't work. Physics equations break. Models fall apart. It's the scaffolding under modern science, even if the final structure might not be infinite at all. You close your metaphorical eyes and try to feel what an infinite universe would mean. No center, no edge, no final curtain drop. Just stars and dark matter, and expansion and silence repeating forever. It sounds overwhelming, but weirdly, also peaceful. Because if the universe is infinite, then nothing is ever truly alone. Somewhere out there, a version of everything exists, every sadness balanced by a joy, every mistake echoed by a triumph, every lonely drift matched by a welcoming shore. And maybe that's the real gift of infinity, not as a number, but as an idea. Not as an answer, but as a hope. You find yourself drifting deeper into that hopeful infinity, but now you realize that infinity, while grand, is only part of the story. There's another idea just as baffling and maybe even more unsettling. What if the universe is finite? You blink. Finite? But didn't we just agree it could go on forever? Sure, but maybe not. Imagine a perfect sphere, like a soap bubble, but on a cosmic scale. No edges, no boundaries. You could travel in one direction and eventually arrive back where you started, like walking around the globe. That's the essence of a closed universe. It's not a flat infinite plane, but a curved finite space with no borders. Think of it like this: the universe could be the surface of a balloon, but in 3 dimensions. You're inside that balloon flying through space-time. The farther you go, the more space curves beneath you. This is more than just a cute analogy. Mathematicians call it a positive curvature universe, and it's been one of the big debates in cosmology for decades. Recent measurements like those from the Planck satellite suggest the universe is incredibly flat. But incredibly flat still leaves room for tiny curvature. Historians still argue about the precision of those measurements, and whether the universe could be slightly curved but on scales so huge we can't detect it yet. If the universe is finite like this, then it means there's a limit to how far space stretches. It's like the cosmic version of Pac-Man. Travel far enough, and you reappear on the other side. This shape would also mean the universe doesn't have an edge or a center. No walls, no borders to crash into, just a continuous space, looping on itself. Now here's the kicker. A finite universe still might be unbounded. That sounds like a paradox, but it isn't. It just means there are no edges to fall off, even though the total volume is limited. You float in this idea, wondering how it changes your perspective. If space is finite, then the total amount of matter and energy in the universe is also finite. That means a limit to how many stars, galaxies, and planets there can be. Maybe even a limit to the number of possible versions of you. It makes existence feel smaller, but in a comforting way. Like you're part of a grand design, rather than an infinite scatter of endless chaos. But the shape of the universe affects more than just distance and size. It influences how the universe evolves. In a finite, positively curved cosmos, gravity might eventually win. Expansion could slow, stop, and reverse into a big crunch, a collapse, back to a fiery singularity. Remember the big crunch? It's the cosmic version of a breath. Inhale, then exhale. Historians still argue if the Big Crunch was ever a serious candidate for the universe's fate or just a cautionary tale. But with dark energy in the mix, the Big Crunch seems less likely now. Still, if dark energy changes over time, or if new physics emerges, the idea could come back. If the universe loops back on itself, then time and space might be more tightly woven than you think. Some theories propose a closed time-like curve, a fancy way of saying time could loop, just like space. That opens a can of paradoxical worms. Time travel, causal loops, the grandfather paradox. You try not to think about those too hard because your brain hurts just imagining it. You float through this space, feeling the weight of these cosmic possibilities. Infinity or finite, flat or curved, open or closed. The universe laughs softly, letting you ponder without giving answers. One quirky tidbit: some astronomers have looked for signs that the universe loops back on itself by searching for repeated patterns in the cosmic microwave background, like a cosmic kaleidoscope. So far, nothing definitive, but the hunt continues. You feel a sense of calm wash over you. Whether infinite or finite, the universe is beautiful in its mystery. The question of its shape and size isn't just about measurements or math, it's about your place in the grand expanse. And no matter what, you're floating here, in this remarkable moment of knowing just enough to be amazed. The universe may be finite or infinite, but your journey is uniquely yours, and it's just beginning. You drift now from cosmic scale back down to a more personal perspective, your place in this vastness. Imagine the universe not just as space or time, but as a living, breathing story you're part of. And the question, is the universe infinite, becomes a question about meaning, about how you fit into the endless or finite dance. You're not just a spectator, you're a participant. Your atoms were forged in ancient stars. Your thoughts flicker through a brain wired by cosmic chemistry. It's easy to feel insignificant when staring at infinity, but maybe the opposite is true. In the grand tapestry, you're a critical stitch. Scientists estimate there are roughly 10.22 to 10.24 stars in the observable universe. That's a number so big it might as well be infinite for practical purposes. Yet, here you are, experiencing it all through the lens of a single lifetime. Your awareness folds the infinite into a finite moment. It's a paradox that human beings wrestle with constantly between the vastness of the cosmos and the intimacy of our own experience. Here's a quirky tidbit to ponder. Some physicists argue that consciousness itself might be a way the universe knows itself. Carl Sagan famously said, "We are made of star stuff." But what if that star stuff is also the universe's way of becoming aware? Historians of science still debate the implications of this, whether it's poetic metaphor or an actual clue to how consciousness fits into the cosmic puzzle. You might even imagine that whether the universe is infinite or finite, your curiosity, your wonder, your search for answers is what gives it shape. Your questions stretch beyond light years, bending the cosmic fabric. And speaking of fabric, let's talk about the shape of space-time again. It's not just space that might curve or loop. Time itself can warp under gravity. Black holes, for example, twist space-time into crazy shapes, creating what's effectively a one-way ticket to nowhere, or perhaps everywhere, depending on who you ask. You can picture yourself as a traveler in this cosmic sea, riding waves of gravity and light. Your journey isn't just physical, it's philosophical. The boundary between here and there blurs. The edge between finite and infinite becomes fuzzy. Historians still argue about how ancient cultures conceptualized infinity and space. The Greeks wrestled with Zeno's paradoxes. The Indians pondered endless cycles of creation and destruction. Medieval thinkers debated whether infinity existed in the real world or just in God. Now your modern mind is caught in that same cosmic dance. You wonder if understanding the universe's ayin or shape is even the point. Maybe it's the mystery itself that drives us forward, the longing to explore, to know, to push beyond limits, both physical and mental, that makes you human. In this moment, wrapped in cosmic quiet, you feel a connection not just to stars or galaxies, but to the whole vast, mysterious universe. Infinite or finite, it is your home. You breathe deeply, letting that sink in. Your journey through the cosmos continues, not in light years or numbers, but in moments of wonder like this. The universe isn't just out there. It's inside you too. As you continue your journey, you start to realize that the universe's size, whether infinite or finite, raises deeper questions about the very nature of reality itself. You begin to wonder, is the universe all there is? Or could there be more beyond what even the most powerful telescopes and theories can reach? This is where things get really intriguing. Modern physics introduces the idea of the multiverse, a collection of many universes, each potentially with different laws of physics, different constants, maybe even different dimensions. It's a mind-bending concept. You live in one bubble, but countless others bubble beside it, each with its own rules. Some universes might be eerily similar to ours, with slight variations. Maybe a version where you took a different path in life. Others might be completely alien, with physics so strange it boggles the mind. This idea grew from attempts to solve puzzles in quantum mechanics and cosmology. For example, the theory of inflation, the rapid expansion of space just after the Big Bang, suggests that while our universe grew to a vast size, other regions might have expanded differently, creating a patchwork of many universes. Historians still debate how seriously to take the multiverse concept since it's difficult to test experimentally. Some say it's more philosophy than science. Others say it's the next frontier. You float in this sea of possibilities, feeling your mind stretch beyond traditional boundaries. The multiverse challenges the very idea of the universe as a singular thing. Maybe infinity isn't just in space or time, but in the number of realities themselves. It's a comforting and disorienting thought all at once. If there are infinite universes, every possible outcome you imagine, no matter how wild or unlikely, actually happens somewhere. Your choices, your fears, your dreams might be playing out endlessly across cosmic realms. On a more quirky note, some speculative theories suggest these universes might occasionally bump into each other, causing cosmic collisions that could leave subtle imprints in our own universe. Searching for these signatures has become a hot topic among cosmologists. You think about what that means for your sense of self. If every version of you exists somewhere, what does you really mean? Historians still argue about how different cultures viewed parallel realities. Ancient Hindu texts describe endless cycles of universes being created and destroyed. Some Native American traditions speak of overlapping worlds layered like feathers. You wonder if your own experience of the universe, finite or infinite, singular or multiversal, is just one story in a cosmic anthology. And maybe, just maybe, the question isn't, is the universe infinite, but how does this vastness make you feel? You smile gently, knowing the journey is far from over. You continue to drift, letting the multiverse idea settle into your mind like a soft whisper. But with all these possibilities, your thoughts turn to the limits of observation. After all, no matter how vast or infinite the universe might be, there's a hard boundary to what you can actually see, the observable universe. This observable bubble is defined by the speed of light and the age of the cosmos. Since light travels at a finite speed, you only see objects whose light has had time to reach you since the Big Bang about 13.8 billion years ago. That means the universe beyond that bubble is a mystery. Could it be infinite? Maybe. Or it might be a patchwork of different regions, each beyond your reach. As you float on this cosmic edge, you realize how much your knowledge depends on light, the universe's ancient messenger. But there's a catch. The farther away you look, the younger the light you see. So when you gaze at distant galaxies, you're actually peering back in time. You smile at this cosmic time machine. Watching the sky is like flipping through a photo album of the universe's past. Here's a quirky bit. Scientists have used the cosmic microwave background radiation, the afterglow of the Big Bang, to map the oldest light in the universe. It's a faint, uniform glow that fills all space, a cosmic relic that's about 13.8 billion years old. Historians of science still debate whether the discovery of this background radiation was the final nail in the coffin for steady-state models of the universe. It helped confirm that the universe had a beginning, rather than existing eternally unchanged. You ponder that the observable universe is a cosmic stage, limited but vast, filled with galaxies, stars, planets, and us. But beyond that stage, it's like standing at the edge of a dark forest, wondering how far it stretches and what creatures might lurk. The boundary you see is not a physical wall, but a limit of perception. Beyond it, space might stretch forever, or it might curve back in on itself. Or maybe the universe is so complex and strange that your understanding can only ever skim the surface. This idea humbles you. No matter how much science advances, there will always be mysteries that tease the edges of your knowledge. And that's part of the cosmic charm. As you imagine the universe beyond your observable horizon, you feel a quiet awe. The unknown is vast, yet but it invites you to keep exploring. You think about the ancient stargazers who looked up at the night sky and wondered the same questions. Their eyes didn't see as far, but their curiosity was just as infinite. You carry their wonder with you as you float through space and time. And for now, that's enough. You begin to feel a gentle tug as your mind wanders toward the role of dark energy in this cosmic puzzle. This mysterious force, discovered just a few decades ago, it is the key player in how the universe expands and whether it might be infinite or finite in its future. Dark energy makes up about 68% of the universe's total energy content. That's right, most of what exists is invisible, elusive, and we only detect it through its effects. It's like the universe's secret puppet master, pulling strings to accelerate expansion. You picture the universe as a loaf of raisin bread rising in the oven. As the dough expands, raisins move farther apart. Dark energy is what causes the dough to rise faster over time. Before its discovery in the late 1990s, scientists thought the universe's expansion might slow, stop, or even reverse into a big crunch. Instead, dark energy speeds it up, pushing galaxies away from each other at an ever-increasing rate. Historians still argue how revolutionary the discovery was, because it overturned decades of cosmological thinking and sparked a crisis in physics. You float amidst galaxies drifting apart faster and faster. Eventually, if dark energy remains constant, distant galaxies will slip beyond the cosmic horizon, becoming invisible forever. The universe will grow colder, darker, emptier. A quirky twist. Some theories propose that dark energy isn't constant. It might change over time, decaying, fluctuating, or interacting with other forces. That would rewrite the universe's fate yet again. You wonder if the universe's ultimate size depends on dark energy's behavior. Will it expand forever into infinite space, or will it slow down, settle, or collapse? The answer remains elusive. There's an ongoing debate among physicists about the nature of dark energy itself. Is it a property of space-time, a new field, or evidence of new physics beyond Einstein's theory of general relativity? Your mind stretches to accommodate these questions. The universe is a dynamic, evolving system, not a static stage, and your role as a curious observer feels even more vital. You start to appreciate that understanding the universe's limits, its shape, size, and destiny requires grasping forces that remain largely mysterious. It's humbling and exhilarating. In this cosmic theater, dark energy is both the scriptwriter and the wild card, keeping the story unpredictable. You lean back, feeling a cosmic breeze brush past. The universe's vastness isn't just about space, it's about the forces shaping it. And dark energy is the universe's secret whisper. Now you start to wonder about the most profound question of all, the universe's origin and what that might mean for its finiteness or infinity. The Big Bang Theory tells us that the universe began around 13.8 billion years ago from a hot, dense point. But what was before that? Or was there even a before? You imagine that singular moment, where all space, time, matter, and energy exploded into existence. The idea is almost impossible to wrap your mind around. It's like trying to picture the first note of a song while the music is still playing. Physicists have tried to peer beyond that singularity using quantum gravity theories. Some propose that the universe might have bounced back from a previous contraction, suggesting a cyclic or oscillating universe. Others imagine a multiverse where countless big bangs happen like fireworks in the night. Historians still argue how ancient civilizations interpreted cosmic beginnings. The Greeks had chaotic beginnings. The Norse imagined a giant cosmic egg, and many creation myths embrace endless cycles. You picture your own existence nested in this vast unfolding story, a single chapter in a cosmic epic that might stretch backward and forward infinitely. This raises a curious thought. If time itself began at the Big Bang, can the universe be infinite in time? Or does infinity only apply to space? That's still an open question. Some cosmologists argue time could be infinite in one direction, but finite in the other. A quirky tidbit, some models propose that time is like a loop, connecting the universe's beginning and end, though that's more speculation than consensus. You sense the humbling limits of human knowledge, but also the thrill of the quest. And just like before, You remind yourself that the universe's origin is not just a scientific problem, it's a story that touches your very sense of existence. In the quiet vastness, you find comfort in the unknown. You are part of an unfolding mystery as much as the universe is part of you. Your journey continues, deeper into questions without answers, but with plenty of wonder. And that is a cosmic gift. The universe's vastness, its possible infinity or finiteness, its mysterious beginning and unclear end. All these cosmic riddles lead you to a final, soft landing. You settle into a gentle reflection on what it all means for you right now, here in this quiet moment. The universe, infinite or not, is more than just space and time. It's a vast stage for your story, a backdrop for every breath, thought, and dream. You imagine the stars twinkling softly outside your window, ancient lights traveling billions of years to reach you. Each flicker is a whisper from the past, a reminder of the universe's grand timeline. Remember how we talked about cosmic curvature, dark energy, and the multiverse? Those vast concepts can feel overwhelming, but they also show how much wonder there is to discover. Maybe infinity is not just about endless space, but endless possibility. And finiteness might mean every moment is precious, every connection meaningful. Historians still debate how humanity's view of the cosmos has shaped our cultures and philosophies. But one thing is clear: our curiosity about the universe connects us across time and space. You breathe deeply, feeling a quiet calm as the questions soften and the night grows deeper. Your place in the universe is small, yes, but also significant, like a single note in a vast symphony. And just like that, you drift closer to sleep, your mind humming gently with the universe's timeless song. The stars watch over you, constant and patient. Infinite or finite, the cosmos holds you safely in its embrace. Now, as your eyelids grow heavy, let the mystery lull you. Remember, you are part of something beautiful and wonderfully unknown. Good night, traveler. The universe, with all its mysteries, whether infinite or finite, feels like a vast ocean of possibility, gently rocking you in its cradle. As you lie here, the vastness doesn't overwhelm but soothes. Every star's light, every whisper of cosmic dust, is a reminder that you belong to something far greater than yourself. The questions about the universe's size and shape are not just scientific puzzles. They are invitations to marvel, to wonder, to feel connected to the endless dance of existence. Whether space stretches beyond what the eye can see or curves back on itself like a cosmic loop, the mystery is what makes the journey so rich. As you let these thoughts settle, imagine the soft hum of the cosmos, a steady rhythm beneath all the noise and distraction. It's patient and eternal. You are part of this rhythm, a small yet vital beat in the cosmic song. The night wraps you gently, the stars keeping watch as you drift deeper into rest. The universe doesn't demand answers right now. It simply invites you to dream. Rest well, knowing that you are held in the universe's vast embrace. And when you awake, the stars will still be there, waiting to share their stories. Sweet dreams, dear traveler.